graph by plotting points. We're not going to do that because we're in calculus. It kind of annoys me. Like, we're not going to plot points to do a graph because this is Algebra 1. What we are going to use are transformations. And we'll talk more about it later in Chapter P. We'll talk about transformations and stuff. Yes. Okay. But for right now, you at least know some stuff about transformations, so you can kind of graph most of these using transformations. So we're going to use HEVO. If you had me for Algebra 2 or Pre-Calc, I don't know if anybody had me for Pre-Calc. I don't know if anybody had me for Algebra 2. No. So I'm going to use HEVO, which means horizontal inside. So if it's an inside operation, I do a horizontal shift left to right. If it's an outside operation, I do vertical. So that's kind of how I keep track of transformations. So we're always going to start with our parent function. And like I said, we'll talk more about this in a couple days, but I'm not going to graph by points because you can do transformations. So as I look at this, my parent function is going to be what? Parabola, x squared. Okay. So when I say a parent function, it's kind of like the basic take away all your operations, take away the -3, I just have an x squared. So my parent function is just going to be x squared. So if I just go ahead and, let me just real quick. Okay, so I always kind of like starting with my parent function. You don't have to draw, parabola is pretty easy, so you might not have to draw a parabola, but we're going to start with my parent function, which is x squared, so it's a parabola. And I want to use transformations to get my new graph. So as I look at this, I notice I am subtracting 3 on the inside. So if it's inside, I know I'm going to have some sort of horizontal shift. So either left 3 or right 3. And the thing to remember about the inside is always what? Opposite. So if I'm subtracting 3 on the inside, the opposite is going to tell me I'm going to go which direction 3? Inside, so horizontal. So I'm going to go right 3. So 1, 2, 3. 1, 2, 3. Okay? So you can just take all your points, or a couple of your points, and shift them right 3. Okay? That takes a lot less time than plotting points. And like I said, we're not in algebra, so we don't have to plot all these points. And we're not going to do a ton with transformations in P1, but we'll get to it in P3. But just kind of a refresher. Okay, I'll put it right 3. Right 3. Okay. Intercepts. So we're going to look at intercepts next. So like I said, Chapter P is kind of a just potpourri of stuff from Pre-Calc. So intercepts, this is from Algebra 2. You found intercepts. To find the x-intercepts, I do what? So if I think about it, if I want to know a point on the x-axis, x-intercept is where it crosses the x-axis. What do I know about my y value? 0. So I'm going to plug 0 in. For y, or you might see it written as f of x. Either one, they're the same thing. So you're going to plug 0 in for y or f of x if it's in function notation, and then I want to find x. If I want to find the y-intercept, which means, okay, I have some point on the y-axis, because I want to know what point does it cross the y-axis, my x value always has to be 0. So we're going to plug 0 in for x. And find y. You've done this before. It might have been a little while since you've done it, but that's how we find the x and y intercepts. Okay, any questions so far? Okay, so let's go ahead and look at example 2. So example 2, we're looking for x and y intercepts. So what we're kind of doing is we're kind of doing what we did with the graphing calculators yesterday, but we're looking at them like algebraically. How do I figure this stuff out without a graph? So if I want the x-intercepts, we're going to plug 0 in for y. So we're just going to take my equation, plug 0 in for y. And I want to solve for x, which didn't really make my equation really that simpler. But anything, if I want to solve this for x, what will I do, which will kind of, or what shortcut can I kind of use? Anytime I have a fraction equal to 0, I basically can just do what? Not necessarily the reciprocal, but if I want to get rid of, yeah, so if I multiply by the denominator, you're good. If I multiply by the denominator, that's basically going to get rid of the denominator because I'm going to be multiplying by 0. So basically all you have to do is set the top equal to 0. So anytime that I'm trying to find the x-intercept and I have 0 equal to a fraction, multiply by the denominator, which is basically just going to give me the top equal to 0. And then how do I solve something like this? It's a quadratic equation because I see x squared. So I have 4 options. Solving quadratics, 4 options. Algebra 1. Not to make you feel bad, but it's good. It's depressing me. Factor is what I'll do on this one. So factoring is what I always try to do if I can. I can also try to do, yeah, that's part of factoring. The other options are quadratic formula. Yes, I can always use that. I hate it, but I can always use it. I can also do, you don't use this a ton. Completing the square is another option. And if I didn't have this x part, if I just had an x squared, I could do, you know it, but you might not, square root. So if I don't have a single x, I can just subtract 3 and take the square root of both sides. So those are the 4. Quadratic formula, factoring, completing the square, square root. I try to factor if I can. That's the easiest one, I think. So I can factor out a what? X. So I'm left with x plus 3. Set each part equal to 0. So I'm going to have, it's going to have an x-intercept at 0 and an x-intercept at -3. I'm going to be skipping some. I'm not going to show every step. So if you're ever confused how I did something, please let me know. It's a nice thing about having a small class is you can interrupt me and we'll be fine. So please let me know. So 2 x-intercepts, which kind of makes sense because I see an x squared up here. So it might have kind of the shape of a parabola. If I want to know the y-intercept, this is a little easier. We're just going to plug 0 in where x's are. So 0 squared plus 3 times 0 over 3 times 0 plus 1 squared. And I'm not going to be super picky. I tend to show a little more work in the notes just so you can go back and see what I'm doing, but you don't have to really show plugging a 0 in your homework. You're in calculus, so I'm not going to be super picky about showing work for every single thing. So I'm going to end up with a 0 on top and a 1 on the bottom, so it's just going to give me a 0. So my y-intercept is 0. Okay. Questions so far? Okay, let's look at example 3. So example 3, let's go ahead and find the x and y-intercept. So my x-intercept, plug 0 in for y. So let's think about this. This isn't a polynomial like the one we did. I don't have a fraction, so I don't have to worry about setting the top equal to 0. This isn't really a polynomial because I have the square root, so factoring really isn't going to work. But what can I do here to kind of find what x will be? If I'm multiplying the x and the square root, I can just do what? Well, it's kind of like factoring, where I have these two multiplied, so you can take 0 equal to each part. So you can do it that way. Okay, you could do it that way because we're multiplying those two. Or just kind of think about it. Sometimes thinking about it is kind of easier than trying to actually solve it by doing algebra. Let's think about this. I literally want to know what values of x can I plug in here that will give me a 0 back. So if I look at here, the only option here, or one option, is this x value being what? 0. So that's one option. X can be 0. So then let's look at the square root part. What would this have to be, or what could this be that will give me a 0 in the square root part? 4. So if I plug in a 4 here, I would get 16 minus 16. Or if I plugged in a negative 4, I would get 16 minus 16. So my three options are 0, plus or minus 4. So you could either set them all, both parts equal to 0, square root or square both sides, solve it that way if you wanted to, or just kind of think about it. So what values of x are possible that will give me back to 0? X either has to be 0 or x has to be plus or minus 4. So either the x part has to be 0 or the square root part has to be 0. Okay? Y-intercepts, easier. Plug 0 in for x. So 0 square root of 16 minus 0 squared. So that would just give me a y value of 0. Okay? So y-intercepts are a little easier. Okay. Any questions so far? Okay, let's look at symmetry. So symmetry of graphs. So symmetric with the y-axis. So what's probably the easiest graph that we know that's symmetric with the y-axis? We already looked at one, actually. Yeah, parabola. So probably the one we're most familiar with is a parabola. So that would be x squared. And actually that would be x to what type of powers? X to any type of powers will always give me a parabola shape. Even, yeah. So x to the even is always going to be symmetric with the y-axis. So if I have x to the 6th or x to the 7th or x to something, that's always going to give me that parabola shape. There might be some stuff happening on the inside, but I'm still going to have kind of that parabola shape. Do I want to say... Yes, I think we're good with that. Okay. So the way you find whether it's symmetric with the y-axis, if it's not an easy one, if you can't see just x squared or x to the 4th, the way you have to look at it is you plug in negative x in for x and get back original. So plug in a negative x for x, and you get back the original. That's how you tell whether something is symmetric with the y-axis, or even symmetry is another word for that. Symmetric with the origin. Let's do symmetric with the x-axis. Symmetric with the x-axis. This one's a little hard. We're not super familiar with. What would be a graph that would be symmetric with the y-axis? You haven't done this very much. May I think of one? If I have a parabola on the side, you don't do these very much. You basically only did these when you did conic sections. But if I would have a parabola on its side, what would be different? Instead of x squared, it would be y squared. So this is going to be like y squared. So this is kind of an example of being symmetric with the x-axis. Is now instead of x to an even power, I'm going to have y to an even power, like that. So the way you find that is you plug a negative y in for y and get back the original. Okay, so kind of the opposite. Instead of plugging in a negative x and getting back the original, you plug in a negative y and get back the original. And then symmetric with the origin. Probably the graph you know that would be symmetric with the origin. I know? Cubed. X cubed, so something like that. So when I say symmetric with the origin, what that means is you can take that graph and literally rotate it like 180 around the origin. So you would rotate it like in a circle, and you would get back the original. So that's what symmetric with the origin means. So that would be like x to x cubed, or all x to the odd. Yeah, any x to the odd, I believe, will also be symmetric with the origin. Now, to find whether it's symmetric at the origin, you have to plug in negative x and negative y, then get back original. Okay? So that one's a little different. If I want to know whether it's symmetric with the origin, you plug in a negative x and a negative y, and that if that gets you back the original, then it's symmetrical with the origin. Okay? So 3, symmetry. We're not going to deal with symmetry a lot. Symmetry is kind of nice when we get to chapter, 4 or whatever, and we have lots of graphing stuff to do. If you can see symmetry, it makes your life easier, but it's just something good to kind of know. So if I look at example 4, and sometimes it's nice just to look at it and kind of say, okay, I'm thinking this might be what? So as I look at example 4, your first thought is it's going to be probably symmetric with the what? Origin. And the reason I see that is because all of my exponents are odd. So you can kind of look at it and get an idea that I only have odd exponents, so I'm thinking it could be symmetric with the origin. But let's go ahead and double check. So symmetric with, let's go ahead and just check all 3 of these real quick. So symmetric with the y-axis, I plug in a negative x. Where x is, and it's symmetric with the y-axis if I get back the original. But if I think about it, what's a negative to a third power? Negative to any odd. That's going to stay negative. And that's going to be a negative. So do I get back the original? No. So I don't get back the original. So it's not symmetric with the y. Let's go ahead and plug in a negative y, where y is. So I'm checking something else. So what will I have to do here to try to get back the original? Divide by negative 1. So obviously that's not going to get me back this original, because that's going to give me back negatives. So that's also not going to work. So I'm just going to I'm kind of taking you through the whole process. So if you can kind of see, this looks like, because I see odd powers, this looks like origin, you can kind of skip, but I want to do all 3 of them with you. So let's go ahead and check the origin. So I'm going to plug in a negative y and negative x's. And see what I get back. And this is kind of what I'm saying. You don't have to show all this step-by-step work necessarily on your homework, as long as you're comfortable with knowing how to do it. So I'm going to have negative y equals, just like we did the first one, negative x cubed minus x. If I want to try to get back the original, I need to do what? Divide by negative 1, which will get me back the original. So this is symmetric with the origin. Okay. Any questions so far? Okay, let's look at another example like this. So let's look at example 5. Same sort of thing. Let's see whether it's symmetric with the origin, or let's see, this one's harder to see. I see xy, I see x squared, so I'm thinking maybe symmetric with the y-axis, but it's not a nice polynomial, so it's not really, it's a lot harder than example 4 to kind of look at and say, this is probably it, or this is probably it. So let's go ahead and check all of them. So let's go ahead and plug in a negative x, where x is. I'm checking symmetric with the y-axis. And just by looking at it, am I going to get back the original? No. This will make it a negative x squared, but I'm still going to have the negative xy out here. So just kind of by looking at it, you won't be able to get back the original. So let's go ahead and plug in y, a negative y. And we're going to kind of run into the same issue. If I plug in the negative y, that's going to give me a negative xy minus the square root of 4 minus x squared. And there's not, I mean, I could divide by a negative, but then that would turn this into a positive square root, which isn't the original, so that's not going to work. So then let's go ahead and plug in a negative for x and y and see if I get back the original. So if I plug in a negative for x and y, so negative x times negative y minus the square root of 4 minus negative x squared equals 0. Right now, space here. Now let's see, let's do some simplification. So negative x times negative y, positive xy, which is close, at least that's part of the original, that looks similar. And then this negative x squared, that will just make it a positive x squared, which is basically going to keep the same thing in there, which gives me back the original. So symmetric with origin. So just in practice, you've done this before. It might be a little different than you did in pre-calc. The way they word it is a little different, but same sort of idea. Okay, questions? Okay, let's go ahead and look at graphing some of this. Okay, let's go ahead and look at, I'm going to throw this in there. It doesn't say it on the home, and you don't have to necessarily do this on the homework, but it's good practice. Let's go ahead and look at the domain and range of this. So let's just go ahead and do this down here, up here, so wherever. Let's just look at the domain. Let's kind of think about this. So as I look at the domain, I want to know, okay, what x values, domain always goes with x. So what x values can I plug in that will make this an okay equation, basically? First thing I notice, what type, or what do I have in this equation? Square root, and I know just from basic math stuff that I can never take the square root of a what? Negative. So I'm thinking to myself, what x values can I plug in here that will not give me a negative back in there? So what x values am I allowed to plug in there that will give me positive square root of a positive number? So let's think about this. First thing I always start with is I start with what value will give me a 0 in there. And then I kind of find 0 first, and then I kind of go from there. I think that's easier. So what value will I plug in here for x that will give me back the square root of 0? 5. So I know I'm going to have a 5 in there. So I always kind of look at what value gives me 0, and then I kind of go from there. So I know if I plug a 5 in, that's going to give me a 0. Or I can also plug in a negative 5. So I'm kind of thinking 5 and negative 5. Those will give me 0. So I'm just kind of jot those down. So now what I want to kind of think about, and if it might be helpful to kind of write it like this, kind of on a number line, which I know is kind of algebra 1. But if it's kind of helpful to think of this, so far I know negative 5 and 5 will give me 0. So what I kind of like to do is I kind of like checking numbers, and the number line kind of makes it a little easier. Kind of check numbers between these. So if I plug in a number less than negative 5, so if I plug in a negative 6 or whatever, if I plug in a negative 6, will this give me the square root of a negative? Yes, because I'll get 25 minus 36, and I can't do that. So I know it's not going to exist anywhere less than negative 5. So let's plug in a number between negative 5 and 5. What would be the easiest number to plug in? 0. So if I plug in 0, 25 minus 0, I don't really care what number it gives me, but does it give me the square root of a positive? Yes. So we're good with that. Okay. The next one, if I have 5 to infinity, let's just plug in a number here. Let's choose 6 again. If I plug in 6, is that going to give me something I can do, the square root of a positive? No. This also won't work. So if it's helpful to kind of think of it as like find your zeros first, kind of think of it as a number line, and then if I write my domain, it would be from negative 5 like we talked about yesterday, negative 5 to 5. And why do I use brackets in this case? I can include 5, because if I plug in negative 5 or 5, I get 0. So I can take the square root of 0, so I can include negative 5 and 5. So just kind of one way to think about. If you're not good with just thinking about it, which I'm not usually good at it, kind of make a number line and check spots. My range, we kind of talked about this yesterday. Range goes with y. So if y is equal to the square root, what are the only possible y values I can get back? 0 to infinity. Like we talked about yesterday. I can never get a negative number for y, because I can never take the square root of something and get it back a negative. So there's domain and range. Didn't really ask for it, but just we'll talk about it in a couple days, just kind of refresh your memory. Okay, let's go ahead and use intercepts and symmetry to kind of sketch the graph and see what we have here. So let's go ahead and look at this. So we are going to have, let's look at my intercepts. Let's find my intercepts first, x-intercepts. So if I'm looking for the x-intercept, I plug 0 in for y. I have 0 equal to the square root. We can either think about this in our head, we kind of already talked about it, or let me just show you how to solve this. To solve this for x, I do what first? Square both sides, so you get 0 equals 25 minus x squared. And then we can use, it's a quadratic, but there's no single x, so I can use the square root principle or whatever. So subtract 25 from both sides. Try to get x squared by itself, so I can take the square root of both sides. Divide by negative 1. So 25 equals x squared. Take the square root. So plus or minus 5 equals x. So my x-intercepts are negative 5 and positive 5. Okay? Questions? Okay, now let's look at the y-intercept. So if I look at my y-intercept, plug 0 in for x. So I'm going to have the square root of 25 minus 0. Square root of 25 is, actually it would just be a positive 5, because I'm not, what's the word, good reason for that? I'm not actually like solving for x squared. And if I think about this, I know if I look at my range, I know y has to be positive, so I'm not going to include negative 5 if you go back to your range. That's another nice reason to find domain and range. So my x-intercepts are negative 5, 2, 3, 4, 5, positive 5, 1, 2, 3, 4, 5. My y-intercept is 1, 2, 3, 4, 5. Something like that. We kind of see what it's kind of look like. We kind of just look at it. Do I see it? Maybe? Okay. Well, let's just check symmetry. So let's check symmetry. So if I look at this, if I check this symmetry, just by looking at this equation, I'm thinking maybe what? Symmetric with the y, because I see what? So what do I see in this? X squared. I see x squared, so I'm thinking I see an even exponent. That's the only exponent I have is even. So I'm thinking maybe symmetric with the y. So let's check. So let's plug in a negative x value and see if I get back the original. So that will be y equals 25. Negative squared is a positive, so that's just going to keep the negative x squared. So yeah, so it's symmetric with the y. So if it's symmetric with the y, I still don't have it. I still don't really know what's happening in between here. So I know it has to be symmetric with the y. I might now kind of see what it might be. Kind of parabola. Yeah, like a half circle-ish. Not really a parabola because it ends. It doesn't go on forever because the domain can't be here. So it's kind of a half circle. And if I look at the original, I wouldn't expect you to look at this and say, oh, this is a half circle. But what could I do? What one thing could I do here to the original, that would be like, oh, now it kind of looks like a circle. Can I see it? So what one thing could I do with the original one that would kind of be like, oh, if I do this, now it looks like a circle, or part of a circle. If I square both sides, I get y squared equals 25 minus x squared. If I add x squared plus y squared equals 25, that's the equation of a circle. So that's kind of where you get that half circle from, just FYI. Okay? Any questions on that one? Okay, let's go ahead and look at example 7. If I look at example 7, we're going to be looking at, let's look at the domain and range, just because it's something to kind of help you graph. The homework might not actually ask for it, so you don't really need to be too worried about it on the homework. We'll get to it in a couple days, but just kind of refresh domain and range. So as I look at this, it's kind of nice with domain and range to look at what my function looks like. This is just what type of equation or what type of function. Don't overthink this. It's just a polynomial. It's x squared, y squared. I don't have the square root. I don't have like fractions. It's basically just a polynomial. So since this is a polynomial, usually polynomials will have like negative infinity to infinity for your domain and range. Because if I think about this, I want to think about, okay, well, let's see. Is this what am I saying what I want to say? What I mean? No, let's see. I'm going to retract that. If I look at this, just by looking at it, what does it look like? If I see x squared and y squared, what do I see? Circle. I'm thinking circle, but what throws it off from a circle? The 4. So I'm thinking conic sections. It's been a while. It's not a circle. It's probably a ellipse. Ellipse has to be equal to what? Remember? Blake, you should know. 1. Good job. We just talked about yesterday. So x squared over 4 plus y squared over 1 equals 1. So I'm thinking maybe it's an ellipse. So I think I spoke too soon when I talked about the domain and range. I won't worry about it on this one necessarily for right now. But if I look at this, I see x and y are both squares, so I'm thinking circle. But then I have a 4 out front of the y squared, so I'm thinking it's maybe not a circle. So I got it equal to 1, and I kind of get it in an ellipse form, something like that. Okay, so I'm thinking, okay, maybe this is an ellipse. Let's kind of see. So let's go ahead and check my x and y intercepts. So if I look at my x-intercepts, you could graph it. If you want to graph it like a normal ellipse, you could, and find your x and y intercepts that way. I don't really care. In calculus, there's going to be like 5 different ways to do something. So if you choose to do it one way, and if it's mathematically fine, then I don't really care. There will only be a few ways where I'm like, you need to do it this way. So if I'm looking for the x-intercept, plug 0 in for y. So x squared, I'm just going to use the original one. X squared plus 0 equals 4. So x will be what? Plus or minus 2? So finding x and y intercepts isn't really hard because things are going to cancel out. Y-intercept, plug 0 in for x. So it's just going to give me back 4y squared equals 4. Divide by 4, so y squared equals 1. So y will be what? Plus or minus 1. If I look at graphing this, plus your negative 2, positive 2, positive 1, negative 1. So just by kind of looking at it, you can see this is probably an ellipse. And if I look at this, what symmetry, just by looking at my equation, am I thinking it will probably have? So look at your exponents. Exponents are both what? squared, they're both even, so I'm thinking it's probably going to be symmetric with the, think x squared. If it's just x squared, it's symmetric with the y-axis. So let's check that real quick. So let's check whether it's symmetric with the y-axis. So let's plug in a negative x. Is that what I plug in? Yeah, negative x. So if I plug in negative x squared, that gives me back a positive. Do I get back the original? Yes. So it is symmetric with the y-axis. So you can kind of think of it as having that ellipse shape. It's also symmetric with the what?
It's symmetric with the x and y.
Yeah, it's not with, well, yeah, it's actually symmetric with all three. If you check all three, if you plug in a negative y, you'd get symmetric with the x, and it's also symmetric with both of them. Yeah. So it is symmetric with all three. Any other questions? Okay, let's look at points of intersection. Like I said, chapter 3 is just kind of going through random stuff. There's not a lot of like, this is all connected this way. It's just kind of random review. So points of intersection, this should be x squared plus y squared equals 25. So as I look at example 8, I kind of want to think about where do these two graphs cross? And you could use Desmos or your graphing calculator, but you can kind of think about this. This first one, x squared plus y squared equals 25, is going to be a what? Circle. So I know I'm going to have a circle, and I'm not going to worry too much about the graph, but we'll just, I know I'm going to have a circle. This bottom one, a little hard to see, is just going to be a what? Line. X and y both have an exponent of a 1. If x and y both have an exponent of 1, it's linear, so it's going to be a line. So let's think about it. How many possibilities could I have for points of intersection if I have a circle and a line? 2. It could go straight through. That's one option. I could have 1, which means it just hits at one spot. And what's that called? What tangent line? We'll talk about later. So I could have a line, it could hit twice, it could hit once, or it could hit none. It could be not even close. Okay? So I can have 3 options. It could hit twice, once, or 0. So as I look at this, what am I basically trying to find? If you think back to Algebra 1, Algebra 2, Pre-Calc, you did all 3 of those. If I want to know where they intersect, I'm basically looking to find what? I'm looking for the point where they intersect. I want to know the x and y value that work for both of these equations, that make them true. So what are kind of the 3, basically 2 ways I have to find x and y that work for both of them? How do I solve 2 equations? 2 ways. System, so either 2 ways, remember? I think you did this in Pre-Calc. Either this something ION or this something ION. Substitution or elimination. Yeah, so those are kind of what we're basically using here. We want to know where they intersect, so I'm looking for the solution, or x and y that works for both of them. So as I look at this, 2 equations, kind of from what you know about systems, should I do elimination or substitution? Yes, I would do substitution. Elimination would probably not work. Why? Yeah, because, right, so basically with elimination, I want to be able to add and cancel stuff out. And I notice I have x squared and x and y squared and y. So there's not really anything I can do that will cancel stuff out. Okay? So I'm thinking elimination. Substitution. So if I'm thinking substitution, probably a good way to get started, I would solve the bottom for y. So y equals 15 plus 3x. It's going to be messy, but it's doable. You've done it before. So y equals 15 plus 3x. And then substitution, I'm going to do what with the 15 plus 3x part? Plug it in for y in the top equation. So it's going to look something like that. Now this is harder than maybe you did in Algebra 2 or Pre-Calc, but it's the same idea, substitution. And what do you notice? If I'm trying to solve this for x, I should have an equation with just x. I'm going to have to do what here? FOIL, do all that stuff. So let's FOIL real quick. So I'm going to have x squared plus, we're going to FOIL 15 plus 3x, which will give me, so if you need to write it out up here to think FOIL, that's fine, I don't care. First will give me what? First two. No, you're good, yeah. 225. My inside two, when I do 15 times 3x plus 15 times 3x, will give me 45x and 45x, so 90x. And then my last two will give me 9x squared equals 25. So it's probably messier than any system you've done before, but it's the same idea. What type of an equation do I have here? Quadratic. So my first thought is I want to try to do what? Factor if I can. So in order to try to factor, I need to get everything equal to 0. So let's combine what I have. X squared, 9x squared, 10x squared, plus 90x. If I subtract my 25 over, my constant is going to be what? 200. So it's a quadratic like we talked about earlier, so I always want to try to factor first if I can. Factorable, I can do what? Take out a 10. So x squared plus 9x plus 20. At least makes it more doable to kind of look at and see. X squared plus 9x plus 20 factors to x plus 4, x plus 5. Two numbers that multiply to give me 20 and add to give me 9, 4 and 5. And then if I solve this, set each part equal to 0. So I'm going to get x equals -5 and x equals -4, which is fine that I'm getting two answers, because what we talked about earlier is I could have 2 points where they cross. So since I get two x values, that tells me that I'm going to have 2 points where it crosses. It's going to hit twice. So I want actual ordered pairs. So if I know x is -5 and -4, how can I find my y values? Plug it in. Now, don't make your life any harder than it needs to be. If I want to find y, plug it into the equation that's already y equals 15 plus 3 times -5, which will give me 0. So -5, 0 is 1 intersection point. And if I plug in -4, 15 plus 3 times -4, that will give me back 3. So -4, 3 is your other intersection point. Done it before, just might be a little more complicated. Okay, one last one before we move on. Any questions on that one? You got some time for homework today, which is fine. I tried it last semester. I wasn't super great because most of them had math lab, so I wasn't super great about giving them a little homework time. I'll try to be better this semester because not a ton of you have math lab. So just FYI, I'll do my best to at least give you some homework time. Example 9. As I look at this, elimination, substitution. Yep, they're both solved for y. So basically, you're going to take the top part and plug it in for y in the bottom one. So it's just going to be x to the 4th minus 2x squared plus 1 equals 1 minus x squared. So same thing, substitution. So this is what type of equation? X, the degree is 4, so that is, I know what it's called? Quartic. It's a quartic. I don't really care if you know it. I'm just saying. I can feel cool about myself because I know what it is. This is quartic. You can do it the same sort of way. You can try to factor again. So let's try to get it equal to 0. Let's try to factor and see if that works. So subtract 1, add x squared. So it's going to be x to the 4th, negative 2x squared plus x squared negative x squared equals 0. That is factorable. I can factor out a what? X squared. So that's x squared minus 1. Set them equal, so we're going to have x squared equals 0. X squared minus 1 equals 0. So my x values are what? 0 plus or minus 1. And if I kind of look at it, it's not super, x to the 4th is going to be like not just a polynomial, it's going to look like, or not just a parabola, so x to the 4th will look something like, there'll be some crap happening up here, something like that. And x squared is a parabola, so it looks like it crosses 3 times. So we'll look at it. It could. It's hard to draw it, but we'll look at Desmos real quick afterwards. But it looks like it's going to cross 3 times, possibly. So if I know x is 0, x is plus or minus 1, how do I find y? Plug it in, and I would choose the bottom one because it's the easiest. So if I plug in a 0, y is going to be 1. So 0, 1 is 1 point. If I plug in a positive 1, or a negative 1, actually, they'll give me the same thing. Y is going to be, I plug in a positive 1 or a negative 0. So those look like my 3 intersection points. And if you're ever not quite sure, you can always get on Desmos and kind of see, does this look where the graphs would intersect? And it should. Okay. Any questions on that? Should be basically review. It might look a little different, but the big idea should be the same. So homework, let me give you the sheet.